Great. Well, welcome everyone. Thank you for joining us today. We're really excited about this webinar titled With Great Power, Misuse of Electrical Equipment. As I mentioned before, I'm George Costandi and I'm the moderator today. I am the Director of Sales and Marketing at Origin and Cause, and so glad that you guys have joined us. I just wanted to go through a couple of quick points with you first. We're going to be doing a live Q&A at the end of the webinar, so please feel free to submit your questions via the text box um, in your webinar screen there. You could see in the slide just an example of the GoToWebinar panel that should be on your screen. And within that, there are multiple tabs. And for submitting questions specifically for the Q&A, you would hit the questions tab, and then you would submit your questions there. As part of Tristan's presentation, he's going to ask you guys some questions, and your answers would actually not go in this tab, it would go in the chat tab, which should be under the questions tab there. So if you have any questions, you could, of course, just send a message in either tab, and we'll assist you there. We're going to try to get to as many questions as possible within the hour. If we don't get to your question within the webinar time, we promise to follow up with you after the fact to make sure that your questions are answered. All questions are going to be anonymously addressed, and the webinar is being recorded and will be posted on our webinar, on our website, LinkedIn, and YouTube pages. So please feel free to pass them on to your colleagues or use them in team meetings if you wish. We're going to be sending everyone completion certificates in a follow-up email, and most probably that will be taking place for the balance of this week and mid next week. It does take quite a bit of time because it's a manual process, so we appreciate your patience with us. Now, once we complete the webinar today and you close the GoToWebinar window, the program is going to prompt you to answer a few questions, like quick questions, and it's specifically about the webinar. And we'd love to get your feedback, have you give us comments on the speakers, on the content, and any other feedback that you may have. Also, if you're experiencing any technical difficulties, you can email our team questions to webinar@origin-and-cause.com. All right, so I'd like to introduce to you our speakers today. First, we have Saeed Ismail. He is an electrical forensic engineer with over 15 years of industry experience. He's overseen thousands of electrical incident investigations, including equipment failures, work injuries and fatalities, and improper installations of electrical equipment. His technical specialties include electrical and electronic failures, product liability, and electrical codes and standards. Our next speaker will be Tristan Delorme. Actually, he's going to be kicking off the presentation. So Tristan Delorme is joining us from our Ottawa office. He's an electrical forensic EIT with a degree in electrical engineering, as well as biomedical science. He's conducted and assisted in over 300 fire investigations and over 100 mechanical, electrical, and metallurgical lab examinations. His specialties include fires and explosions, electrical failures and malfunctions, product liability, water, and material claims. So I'm actually going to pass off the mic to Tristan, and we'll go from there. Go ahead, Tristan.
Thanks, George. So welcome everyone to the webinar. To start, let's just begin with a quick pop quiz where I ask you all to identify the electrical misuse. If you look at the GoToWebinar toolbar, there should be a drop-down chat box. You're just going to type in the chat what you think the problem or danger is based on the picture I present. So for this slide, we see that someone has installed a shower head that can be controlled by a switch to turn it on and off. What's wrong with it? So type your answer in the chat. I'll give you a few moments for everyone to answer. This is a bit of a difficult one.
Are you seeing the feedback that's coming in here?
No, I'm not actually.
Okay, so let me just read a bunch to you. Exposed wires, electrical wire connections, exposed wiring, wires are not hidden, they're not capped off, chaotic wiring.
That
So
you know what?
people,
That's all great actually. Everyone was spot on. So yeah, the answer is just we have several issues here, but yeah, the big one is that we have conductors that are weakly protected by tape and close to the source of water, allowing for a shock hazard. So very well done, everyone. So for the second picture, same thing. We see an electrical box connected to two things, one being a bag of soil. You do not need to know the function of the box. So what's wrong with the setup? Again, just going to give everyone a few moments. Please type your answer in the chat box, and George, I guess maybe you can help me with just reading them.
okay, so plastic bag uh, close to electrical, bag attached to wires, fire hazard, exposed wire connection, took grounding too literal. That's hilarious.
Yeah, so yeah, you know what? It is potentially a fire hazard if it's too close. But the big one that I was looking for, the correct answer on this one was yeah, that they took the actual ground wire and put it into a literal bag of dirt instead of actually having it as a proper connection to ground. Which in this case, it won't require my engineering degree to tell you that this won't work. So the moral of the quiz is people do find unique ways to modify the electrical system or devices in their homes, and they're not always correct or safe. So I guess all this is to say, so like how frequently do we actually get electrical fires and how much damage do they cause? Well, according to the NFPA, there's roughly about 46,000 electrical fires each year. Additionally, electrical failure or malfunction fires cause an estimated average of 390 civilian deaths and 1,330 civilian injuries each year between 2015 and 2019, as well as an estimated $1.5 billion in direct property damage a year. This is all to say that these types of fires do happen all the time and they are very costly. For this webinar, we're going to be discussing a facet within electrical fires, specifically misuse of electrical equipment. Misuse can take many forms, as we can see here in the photo. It can be installing an electric heater in an enclosed area without proper clearance to combustibles, which will heat much more than just the crawl space once it starts a fire. It can be grounding a plastic coated gas line, thereby removing your safety measures for the house. Similar, I guess, kind of to putting the bag of soil and putting the ground into that. Misuse can also occur from a contractor leaving energized lights in an attic space and then blowing cellulose insulation all around it. One flick of a light switch can then cause a fire, as this photo shows. Misuse can occur when people cut corners. In this photo, we see the armored cable is stripped and connected at the outlet and not connected within the fixture box. It can occur when people have enough knowledge to produce a result, but not enough to understand the risks. In the left photo, we see someone using jumper cables to steal power from their meter base on the exterior of their home. Normally, you would find the meter there. The right photo shows a similar feat, but accomplished with screwdrivers. Misuse may also be from an electrician leaving an exposed, live, uncapped cable in the attic, as seen in the photo. For this file, the electrician had discontinued a branch circuit inside a residential home. The cable was left in the attic and not capped with a twist-on connector. So wire nut as well is another name for it. The branch circuit was left energized and this resulted in the fire. This begs the question, is misuse of electrical equipment much of an issue? Data collected by the Electrical Safety Authority produced for electrical related fatalities in the last 10 years shows 30% occurred from human error. 15% resulted from misuse, misadventure, and theft. The remaining categories attributed 5% each. Improper use or misuse ties for the second highest percentage of all the identified measured causes. We should also note that there may also be more misuse under different categories, such as unknown, human error, and improper installation. The categories in the table are specified by a major contributing factor, which does not rule out other factors being involved within each column. So now let's talk about the most improperly used appliance, ranges. As most here are abundantly aware, we get quite a few stovetop fires. Data collected by the Electrical Safety Authority, produced for causes of stovetop fires in the last 5 years, found a large number of the fires were caused by different variations of improper use. The largest being unintended cooking fires, which you can see where it's denoted the number 1 in the photo, which in and of itself is a misuse of the range/stove. Other causes of misuse include children playing, which is number 2, nearby combustibles, which we can see in number 3, improper handling, storage, and discarding, which falls under 4, and accidentally igniting an inadvertent item, which falls under the other category, which is 5. I have had several inadvertent items ignited by tenants, like spice racks, toys, plastic bins, plastic wooden utensils, and pots containing various foods. Something which happens more than you'd think is when people use the ranges as temporary or permanent tables. One such case that I was involved in resulted in the ignition of a spice rack left on an element of the electric range. Unfortunately, the tenant energized the wrong element when she was trying to heat her soup, which ignited the spice rack, resulting in the damage you see in the photo. So in the photo itself, the range is actually just in the back portion where you see my mouse. For this file, we were called to investigate a fire that originated from the kitchen. The info we were given was that the homeowner was at a soccer game when the fire happened and that no one had used the range for a while. Unfortunately, before we arrived, the scene had been modified by the contractor and materials had been removed from the scene. While investigating the scene, we determined that the fire had originated from the surface top of the electric range. The next step was trying to figure out, well, what caused the fire? We had a look around the home and found a bin that was similar to the green plastic you see adhered to the surface top, right where the yellow circle is. It turns out the homeowner placed a box on the surface top intending to put it away, intending to put away their groceries, and bumped the controls into the on position. They rushed out of the home midway through putting away the groceries because they were late for their son's soccer game, and the rest is history. As you can see, it's the right color and even the right height to press against the panel and accidentally activate the cooktop. What we found out later was that the green plastic from the bin had been cleaned up by the contractors prior to our arrival. For these cases, we recommend leaving the scene intact. Instruct the contractor to hold off on modifying the room of origin. Continuing on, some of the possible causes of electrical failures resulting from misuse can be from too much current or damaging the cables. One such way involves overload, which is the operation of the equipment or wiring in excess of its normal rating, possibly causing a dangerous situation where an ignition source is created. This, in fact, can result in overcurrent, which is the condition in which more current flows in a conductor than is allowed by the accepted safety standards. In the left photo, which you can see right here, we see an extreme example of overload in a commercial office building. Now, this hasn't caused a fire, but the possibility remains. The right photo is from a test we conducted where we increased the current beyond the rating of the cable. This caused the cable to overheat and ignite the insulation surrounding it. We can also find examples of overload and overcurrent in commercial settings. In one fire we had, the building was designed for light commercial use and not heavy commercial use. Once the original occupant had moved out, a new tenant came in and utilized industrial equipment. This resulted in greater electrical current usages on the system and created a greater requirement for power. Consequently, a fire occurred within the building's electrical system. For the next 2 case studies, we'll be touching upon misuse of equipment. This first case study involved a failure of an 11-year-old variable frequency drive, or VFD, in a water pumping station. A variable frequency drive is used to control alternating current motor speed and torque. Collected information determined that this pumping station was not the main pumping station. In the 2 months prior to the fire, the pumping station had been utilized more frequently. At the time of the fire, the VFD was under a load greater than it was typically called for, and the main breaker had tripped. Our on-site investigation determined that the fire had originated from a control panel in one of the VFD's control cabinets on the south side of the building. So if you look to the photo, the cabinet is this one in particular right here. And so further information provided determined that the VFD had not had any maintenance completed. This included thermal imaging to identify loose connections. So the combination of stressing the VFD under the greater than normal load and not completing any maintenance resulted in the failure of the device and caused the fire. Equipment should be operated and maintained as specified by the manufacturer. This second case study involved a fire in a digestive blower at a water treatment facility. When we had arrived for the investigation, equipment from the blower had already been removed and modified, which made the investigation much more difficult. And so as you can see again in the photo, what we actually had when we investigated this is there was a motor that was in this location and a rotary low blower, which is in this location, and then there's some cables connecting them, and that had all been removed and was actually out of the picture. So further information determined that we were informed that the 12-year-old blower had been operating, again, similar to the previous case, under a larger than normal load, as sewage had been rerouted to this blower to accommodate the failure of another. Maintenance had been completed recently, but it had been incorrectly done, and the combination of this and the above average sustained load resulted in the failure of the equipment. Again, we see that that equipment should be operated as specified by the manufacturer. Get a thorough maintenance and usage record of the equipment. In our case, we actually had requested and received 12 years worth, was essential in determining the cause, which was related to the misuse. Continuing on with commercial/industrial settings, we have seen cases where transformers have exploded or commercial LED lighting has failed when older models have been replaced by newer ones. In this photo, we have a power distribution center where electricity passes through, is modified, and distributed to other areas. In this file, we found out that a company had newly installed several transformers, all of which exploded. They were unable to determine the problem. In short, following our investigation, we determined that the new models had been installed without properly assessing the old system. The new transformers were not adequately rated for the electrical system and thus were incompatible. This resulted in noise polluting the source, which resulted in overheating in the transformers. The issue was rectified once the transformer was replaced with the properly rated equipment. What's interesting to note is that there are certain regulations to prevent issues like this from happening. In Ontario, transformers over 1,000 volts need to be properly rated, sized, and the plans need to be renewed with ESA. For this file, there was a great subrogation opportunity as the installer should have been aware of the regulations and the ratings. A similar issue can occur when newer lighting, like the left photo, is not properly rated and installed into an electrical system. Capacitors on the circuit boards of such lighting fixtures may withdraw excessive current and vent due to harmonics, as seen in the photo on the right. So again, if we look at this photo on the right, where the arrows are, this is the venting that occurred right there and there. Unfortunately, all these types of losses don't come with nice arrows pointing to the failure mechanism that resulted in the fire or failure. It is essential to leave the evidence untouched and get yourself a forensic investigator to go through all the evidence with a fine-tooth comb. When it comes to a fire or a failure that may involve some form of electrical in residential buildings, commercial buildings, or otherwise, attempt to keep the electrical panels intact. Removing or modifying the panel before we arrive can and likely will eliminate evidence that can be crucial to our investigation. If the power needs to be reintroduced before we can arrive, speak to the contractor/the electrician and have them take detailed photos of the panel and wiring before they modify anything. This way, we retain the evidence should we need it. Our next section's going to begin with cables. So one regular cause of electrical fires when it comes to your homes comes from the damage of cables, whether they be from the building electrical, power cords or electrical devices, or extension cords. That can be from nails, screws, rodents, etc. It can be from physical damage. So before we start, let's just start with, again, another pop quiz. And so I'm just going to ask a couple questions and everyone can kind of type their answers in the chat. So the first question is going to be, how many feet of wiring does a typical single family dwelling have? So we'll give about maybe 10 seconds for people to write their answers in.
All right, so we've got 2,000, 1,500 feet, 1 kilometer, no clue.
So a couple of you are actually pretty close, and it has varied a little bit just as new construction has kind of been built and you have larger homes. The answer is 1,500 feet, but with the newer builds, you're getting closer to maybe around 2,500 feet. So yeah, good guesses. So our next question is going to be, how many feet of extension cords does a typical single family dwelling have as well? And so same thing, going to give a few seconds, everyone kind of take a guess. Just think of your own home, how much you have. Sometimes people have several.
50 feet, 40 feet, 250 feet.
So yeah, so this one,
Approximately 50 feet.
yeah, so this one's actually 200 feet. Generally, it's not uncommon for people to have a couple of extension cords and or several, and they can actually build up pretty quick. So yeah, the answer is about 200 feet. So that in total is a combined anywhere from 1,700 to 2,700 feet of possible failures. And so with that, we're going to pass you off to Saeed's competent hands for the remainder of the webinar.
Thank you, Tristan, and thank you all for having me. So as a follow-up to this pop quiz you just did, as you can appreciate, the electrical wiring and extension cords can be the source of fire. And essentially, when you're talking about extension cord, in the Ontario Electrical Safety Code, it is defined as a flexible cord. And flexible cord has certain criteria and certain uses. And in most cases, the manufacturer will indicate right on the cable itself and on the box what are some of the criteria. So not all cords are the same. Some can be used in indoor settings, some can be used in outdoor settings, and some can be used with certain loads, others may not be able to absorb those loads. So you have to be very mindful of all the information on these extension cords. And where it comes handy for yourselves and for as insurance adjusters is, it's not always the homeowner that gets caught up in misusing certain types of cords. Sometimes they will assign electricians or contractors if it's a home or a facility, and that could be something that's up for subrogation if it results in a fire or an incident of some sort. So you will see here as one of the examples that this particular cord is suitable for use with outdoor appliances, but it also says when you're not using it to store indoors. And you got to be mindful of that, because just because it is allowed to be used in an outdoor setting, it doesn't necessarily mean it can be left outdoors all winter. Now, another thing to appreciate is these wires or these cords, when they are certified, properly certified and tested, you will see some kind of a symbol, certification symbol or approval symbol, such as this one, where it says UL, which is Underwriters Laboratories in this case, and it has a C and a US. A C and a US means that this product is approved for use in the US and in Canada. So when you see that kind of an approval, most of the time it is valid. there are situations where it could be counterfeit. And we could do the proper research for you as forensic engineers and find out this information. Now, when those cords are tested and certified, they're tested in free air, which means, you can appreciate that anytime there's electricity, there is some kind of heat generated. But when cords are tested, they're tested in free air and they're allowed to heat up to a certain point. Now, if you get overheating, in some cases, it could be the result of overcurrent and overloading, as my colleague Tristan has suggested earlier. This is what could be an issue, such as when you have situations like the picture on the left, where it's passing through a crevice or a crease, and this could pinch the cord and create more heat. And another situation, what we call sometimes piling or lumping of cords together, in these two pictures that you can see in the middle and the right, and that can result in some kind of overheating, as well as possibly overloading with all the appliances that are plugged in. So the message here is essentially to try as best as you could to allow the scene to be undisturbed and to leave extension cords in situ. And this could be especially relevant in situations where you have tenants, and if tenant is insured or not. Is there a subrogation potential here? The best situation that you will be best positioned for that if you leave everything as much undisturbed as possible for the forensic engineer or fire investigator to come in and analyze and examine. Another example of misuse that's fairly common from my experience is using your two prongs and leaving the ground pin unplugged. And sometimes it's because of the type of extension cords that's being used. Sometimes you can get these extension cords from dollar stores, and which I highly don't recommend because you don't know where you get those from. And historically, the Electrical Safety Authority and Health Canada has identified a lot of the counterfeit products. They end up sometimes in those type of stores. For electrical particularly, it can be very hazardous. So in this situation, in terms of grounding, what is the ground pin's purpose? So a grounding of any electrical equipment is to provide a path for, in case a situation arises where there's an electrical fault that's trying to find a path to the ground and back to the source. If you have no path, this electrical current that's trying to find a path could take any other conductive surface as its path, and it could create a shock and in some cases a fire hazard. So the potential for that is damage in the circuit on the cord, and it could possibly cause a fire. Further misuse examples are hardwiring, sometimes removing a plug end of an extension cord and hardwiring it into a junction box. Now, these extension cords, or as they're called sometimes flexible cords, have certain purposes, but one of the purposes they're not intended in many cases is to be used for permanent wiring. This type of flexible cord is specifically for temporary wiring, and this is a very high likely candidate for overcurrent, overloading, and overheating, and of course resulting in a fire. One case study we have with an extension cord did have an unfortunate ending of a fatality. And this one was an older home, which is not atypical. You can find that very often where older homes don't have very many receptacles. It's not uncommon to find ones with a bedroom that has only one receptacle for the whole bedroom. And in these situations, a lot of people will go with a cheaper route and just buy some extension cords, and in some cases daisy chain extension cords to have more outlets, which is a big taboo for extension cords, and most extension cords will tell you do not daisy chain, as a matter of fact. And in this situation, a baseboard heater was broken and the owner of the home wanted some kind of heating, so they went and purchased a portable heater to heat the room, and they used it on an existing extension cord and it resulted in a fire, and the homeowner succumbed to her injuries in this case. Further examination and investigation revealed that the extension cord was, first of all, not rated for the use. Secondly, it was an already damaged extension cord. And thirdly, this extension cord did suffer from overheating and ignited surrounding fuels and combustibles, resulting in the fire and the fatality. The next item that is a very common, is becoming more common misuse candidate is a Lichtenberg generator. You may have seen this type of what is called a fractal wood art, and this is created by using a high voltage device connected by typically clamps of some sort to nails that are on a surface, and using some kind of chemical solution to create a path for the current and to create a conductive path, in fact, and create this kind of design. The unfortunate part is, and where the misuse happens, is where people use this essential burning machine by dismantling a microwave, for example, an old microwave, and removing a high voltage transformer. Now you can appreciate that there are exposed terminations and a shock hazard automatically as soon as you energize this item. And there's also a fire hazard surrounding combustibles. There's been several fatalities as a result of this type of misuse. And the interesting part that we found in many case studies is usually people would learn how to do something like this from a YouTube video. And it raises the question, who's at fault? And in one case, one of these fatalities, police investigation identified that the individual who suffered from the shock and electrocution was attending the same page and the same video from the same influencer to create this type of device. Now, can you subrogate against an influencer? And can you subrogate against somebody from online for their part in it, as there was no safety warnings in that video? It's a question that begs to be answered in the new digital world, and it's certainly possible. Next, I want to talk about manual motor controllers, or as we call them, MMCs, and these are more typically used in commercial settings. And essentially, if you look at the left picture, this is it looks like a light switch for all intents and purposes, except it has a much larger load and a much bigger use, as what it does basically is you can use it to turn on and off a motor and a system, maybe possibly a whole line of product on a commercial line. And the intent of it is only basically to use as a switch to turn on and off. But what people have started doing is they've started using it as a disconnecting means. Now, the Ontario Electrical Safety Code defines a disconnecting means as something you can use that's certified and approved to be used as a disconnect, such that you can maintain equipment downstream, and you can remove equipment, you can replace equipment. The manual motor controllers are not necessarily for that, unless, like in these two examples, it actually tells you that you may use it as such, and it says right on it that is suitable as a motor disconnect. So what's been happening, this also is a product that is properly certified. When it's certified to disconnect, it has been tested against disconnecting and to ensure that you can't ever have energy going downstream in it when you disconnect the switch. Unfortunately, people have used the ones that don't have this disclaimer, and they're not tested for it, and this resulted in several fatalities. One of these is a case study of a maintenance worker who was intending to maintain a pump motor and to replace it, in fact, when he found that it wasn't functioning properly. But he used a manual motor controller to disconnect. Unfortunately, what happened was the line side of the motor disconnect was welded, the contacts were welded shut, so energy remained in the pump motor. And when the worker didn't test for energization and went to work on the motor, he was electrocuted. Now, you can see that this can result, from your perspective, for loss of time for work, which is insurance covered in many cases. It can result in penalties to the customers, especially like in something like the automotive industry, where the client's expecting everything to be on time. And it can be down maintenance staff, and there could be lawsuits if it's a contractor. In this one case, there was a coroner's inquest as a result of this fatality, and now added to the newest version of the Ontario Electrical Safety Code is a new code rule that indicates a manually operated across the line type of motor starter that is not marked suitable for motor disconnect shall not be used as a disconnecting means, and shall be field marked A, warning, do not use to disconnect motor. So you can use it as an on-off switch, but you can't use it when you're maintaining equipment. And 2, it actually indicates, it has to indicate now what the disconnecting means is and where is the location of the proper disconnecting means to be able to safely do the work. Now, we as investigators will be looking for this type of thing, especially in this type of environment. And we know what to look for and which code rules that do apply. And finally, we're talking about aluminum wiring and rated receptacles. Now, aluminum wiring tends to be something that scares people in some cases because, you see fires, and many of us may know that aluminum wiring has a lower melting temperature. They were more typically used or installed in between around 1965 to the late 1970s. However, in those homes and facilities of that era, you will still find them to this day. They are less expensive compared to copper. There is a caution that has to be used when you're terminating them, and some scientific analysis would prove that expansion rates for aluminum is greater than copper. So if you're not using it with the right terminations and the right connections, you can end up with loose connections and high resistance faults, and this can lead to a fire. So how do you deal with aluminum wiring? Well, a lot of the older cables that we used were rated for 60 degrees and 75 degrees and may not be used for modern fixtures. So there was the Electrical Safety Authority, ESA, has managed to come up with some solutions, one of them being asking the installers to take further action when replacing, for example, light fixtures, such as using 90 degrees Celsius heat shrink, and that would give some more insulation against failure. Also, a very important factor is to ensure that receptacles and other devices are rated for aluminum. And in fact, you will find that in many cases, they are labeled or stamped right on the product, and it will say CO/ALR or some variation indicating that this receptacle is approved to be used with copper or aluminum wiring. And finally, one more case study involving aluminum wiring involved a fire in a home, and that there was an aluminum wiring to a receptacle that wasn't rated for this wiring, and it was near a headboard and ignited the headboard and resulted in a fire. Now, this house, with further investigation, we identified that this house had aluminum wiring across the home, and there was a heavy load that was connected to this circuit, which was an AC unit. The receptacle was not rated for aluminum wiring. And finally, there was a matter of overfusing, which is basically replacing a properly rated fuse. And in this case, it was an old traditional glass fuse. It was a 15 amp fuse that was put in with what is called a fuse rejector, which is these two items you see nearby here. So in these old fuse panels, you'll find that the fuse is a different size, and the large fuse is the 30 amp. The smaller fuses needed a rejector to fit in to that same socket. And in this case, the individual, for whatever reason, they're having fuses burning out, and they removed the 15 amp fuse and replaced it with a 30 and the rejector and replaced it with a 30 amp fuse, resulting in overfusing the circuit. And with that, I will send you back to George.
Thank you very much, Saeed. So we're going to open the floor to you all to submit your questions. As mentioned before, in the questions tab in your GoToWebinar console, you have the opportunity to type in your messages. We've got a few come in already, so let's get started. So I'll start with the first one here. Why do they allow 16 gauge wire when the average circuit is 14 gauge? Tristan or Saeed, you guys could decide who answers that.
So I can take that on, as it's more so an Ontario. Well, I keep referencing the Ontario Electrical Safety Code. I'm mindful that that you may be from different parts of Canada, and the Canadian Electrical Code is fairly similar to the Ontario Electrical Safety Code. The Ontario Electrical Safety Code is in fact a variation with some Ontario amendments. So whenever I mention Ontario Electrical Safety Code, forgive me, I'm just used to using that terminology. But in general, for that or for any other case, allowing a certain sized wiring is you look at it as a whole system. It's just one small piece of the puzzle. So wires, fuses, whatever the receptacle type, the terminations, everything is looked at as a whole system and through certain calculations. Now, obviously, 14 gauge is safer as being a larger gauge wire, but if there is usage for 16 gauge, it will be because it was measured with a proper evaluation, and still under normal circumstances wouldn't cause any hazards. I hope that that helped.
Great. Next question. Can we use outdoor cords inside?
Absolutely. So outdoor cords will generally have the rating, all the same ratings as indoor, plus usage for in the outdoor and the weather elements. So essentially, there's no limitations on indoor usage. Of course, I am not to be mistaken. When I say free air, it doesn't mean free air as in outside. Free air as in unobstructed. So as long as it's unobstructed, indoor or outdoor, the outdoor rated cords should be okay.
Great, thank you. All right, the topic of infrared or thermographic inspections might have been mentioned, but can you suggest the role of IR inspections of power equipment and frequency of such testing?
So what was, sorry, just if you can repeat that. Tristan, you might be able to help with that as well.
Okay. The topic of infrared or thermographic inspections might have been mentioned, but can you suggest the role of IR inspections of power equipment and frequency of such tests? Okay, it seems like Tristan was having a hard time with his mic.
Yeah, sorry, I wasn't able to unmute myself, I think, just due to probably technical difficulties. Yeah, so it would be dependent on the safety measures involved with a specific, I guess, company. They'll devise a plan, they'll devise kind of the maintenance as far as the frequency, what they do specifically. It'll be dependent on the equipment, depending on the facility, dependent on also the manufacturer's instructions as well. As far as the thermal imaging, it'll allow you to see hotter areas than I guess within the actual specific unit. So you can use that to potentially protect yourself or find early detection as far as like a loose connection, because your loose connections will generate heat. So in that case, the thermal imaging would have been able to potentially prevent the fire in the VFD in that one. As far as the frequency, it'll really just be dependent on the type of equipment you use, how much of a maintenance schedule is set up, and then the organization will kind of depend and choose that as well. So the best thing you can almost do is if you get, I guess, a file that involves that, it'd be to get the history of the maintenance records, and then you can start to look at what was done, compare that to the manufacturer's information, if that's even listed, and then you can start to, I guess, within reason, also check out how frequently it's used too, and use all that to kind of determine whether it was appropriate or not.
Thanks, Tristan. Next question. What is the life expectancy of a baseboard heater typically?
As far as the life expectancy on those, I mean, they can be quite a long time. They're essentially a big metal box that's contained. And I mean, as far as even units, I do a lot of kind of older buildings, and those have been around for years and years, and you really don't see too many that actually involve fires from the baseboard heater. So they can be quite a bit of time. As far as life expectancy, it's hard to put an exact date. It would be varied and dependent on the manufacturer themselves, sometimes a bit of the quality of the products that they use or the components as well. So it's hard to give an exact date, but they are pretty long. Yeah.
Okay. And I'll add another piece to that. Also, in addition to what Tristan said, if any, just like any other electrical product or device or equipment, if they are certified properly, if they are maintained properly, the life expectancy can be a lot longer. So if you ask the manufacturer from a certification perspective, what is life expectancy? In a lot of cases, they won't put a number on it, and there won't be something that you would call an expected time, the way they would expire, for example. So it's just a matter of proper maintenance that would extend the life of the product. And you'll find in a lot of fires, I mean, in a lot of situations, I'm sure Tristan has seen it, and many of you may have seen, when products aren't maintained properly, sometimes they're much less likely to last even a reasonable amount of time.
Great, thank you. Next question. Can a standard 15 amp circuit breaker be shut off and turned on several times weekly and not present a hazard? Used sort of like a light switch, but only operated a couple of times per week. Oh, that's interesting.
So one thing you have to appreciate is, and there's actually an Ontario Electrical Safety Code rule about this, that devices are to be used, or equipment is supposed to be used as intended. And unfortunately, as much as this may be more common than we would like to admit for circuit breakers, I don't believe that that is the intent. And you can very easily research it with any manufacturer, and they'll tell you the circuit breakers intended. The purpose of a circuit breaker is to tell you there's an issue. If a circuit breaker trips, that's another issue that we've seen that's predominantly in the field. The fact that people think that if it trips, I can just, flip it back on. And unfortunately, they ignore the fact that there's an underlying issue why this is tripping. So imagine taking it a step further and saying, hey, I'm going to start using it as a switch. Now, the actual credibility and integrity of that switch or that breaker is compromised. You can imagine if it's regularly used, and will it really tell you if there's an issue down the road when it's supposed to trip during some kind of abnormal electrical activity? So that's the question you got to ask yourself.
I imagine that there's some sort of testing done on the breaker switch to be able to withstand, like, I'm sure it has its own life expectancy or something. Is that accurate?
Yes, you got it, George. So there are absolutely, definitely some testing and to allow for it to behave, allow for it to be flipped and tripped several times. Unfortunately, there's that, you know, every time you flip a breaker, it takes away a little bit of that, and it's you're activating or deactivating an electrical circuit. So you have to appreciate trying to do that a couple of times a week or more. Might really hurt the integrity of that breaker and shorten its life.
That's a really great question. Thank you for submitting that. Next question. Can you talk about pigtailing for aluminum wiring?
Yeah, I'm not sure exactly what the specific question is, but I guess it would all be dependent on, again, the materials used, as long as you're using appropriate materials to connect them up. Basically with aluminum, like Saeed had previously mentioned, it has, it'll expand and I guess shift the connections more than copper, since copper is a bit more robust. So you would have to use something appropriate for aluminum in order to be able to do it for one. Yeah, I'm not sure exactly what other the question might be asking, but if you have other something more specific, you can always put it in the chat and we can just follow up on it.
Yeah, and I'll add to that. Thanks, Tristan. I'll add to that from the electrical safety code side, just for your own info, it doesn't discriminate between copper and aluminum. There's not much in the way that says for aluminum you should do things in a certain way. For copper you should do things in a certain way. It's more broad that it tells you that you have to have a reliable connection. That's all it says basically. You use the proper equipment, you use the proper wire nuts, or as some of us call it, morettes. I remember when I was in a training course down in the US, they didn't know what a moret was, so we had to make sure to use the proper terminology, so wire nuts. But it's as long as you use the proper devices or tools, you should be getting proper connections and hopefully not leaving fire.
Great. Next question. If an electrician finds aluminum wiring in a home, are they legally obliged to inform the authorities?
So when you talk about authorities in this case, I mean, I guess it will be the Electrical Safety Authority in Ontario, and in other provinces, whatever the regulating authority would be for electrical wiring. I don't know of any jurisdiction where aluminum wiring is illegal, so I'm not sure why they would have to inform the authorities. I think it will be due diligence to inform the homeowner or the facility owner to understand what type of wiring they have and to inform them if there's anything that's not conducive or compatible with that wiring, because that could be a potential hazard. So if I'm a licensed electrical contractor, I would absolutely do my due diligence from that side of it, so that I don't put myself at risk, because if I did any wiring and I noticed something, and then, for example, you get a fire as an adjuster, and you want to, in Ontario, you want to pull the records, you can actually ask for records from ESA, for example, the Electrical Safety Authority, and they'll give you the permits, and you find out there was a job that was done recently by an electrician. Well, did this, as a competent person, know that there's aluminum wiring, and did they know that there was any issues that could have been the result of this aluminum wiring, and not inform or recommend changes or inform anybody? In that case, you got to wonder what's the subrogation potential in that kind of situation. But in and of itself, for the purpose of the question, do you have to inform somebody for aluminum wiring? Not that I'm aware of, if there's no hazard involved, because again, aluminum wiring is still useful, but in the right situations when with proper caution taken.
Yeah, to further add to what Saeed said, aluminum wiring can be completely safe. It just has to be, I guess, one, installed correctly, and two, it's one of the big issues comes more so when you start to connect it to copper and you make new connections and things like that, because people will sometimes, I guess, like Saeed mentioned, they'll use maybe inappropriate connections or inappropriate receptacles that aren't rated for it as well. And so because they have different expansion ratings, then that is one of the issues that can arise. So it's more so, it's fine as is. It's when people really do new installations, they do modifications to the system. If they're not fully aware of how the system is set up and what each thing is rated for, then that's where issues might arise once they start connecting and tacking on more so than anything. But yeah, aluminum is still used, and you still find it in homes. And like Steve mentioned, it can be perfectly fine.
Great. Why do some appliances have a ground prong on the plug, yet many do not? Are these appliances more prone to faults?
Yeah, some just has to do with age, and you'll see it on some of the older appliances where they just didn't have it. And with the newer ones, it's more common, especially with shock hazards. As far as safety goes, it would be preventative as far as you getting a shock, and it would also depend on like the composition of the body of the appliance as well. But it would also be dependent on the internal safety measures. Like sometimes you'll get like thermal cutoffs that'll be employed more so in newer models, and you'll have other built-in safety mechanisms. So inherently, I would say not necessarily more safe with the ground, but it does provide that extra measure. So, and then you have other built-in safety mechanisms just because of the newer models or the newer appliances. So a little bit, I guess.
Okay. Next question. Why are extension cords not banned? I imagine the reason why this is being asked is because they are a common source of fires. But I imagine also that there is probably a safety standard that sufficiently makes extension cords safe. But that's for you guys to comment on. Tristan, Saeed, do you have any thoughts?
Yeah, of course. It's
Go ahead.
yeah, I was gonna say, of course, it's they're perfectly safe when used correctly, and the problem is a lot of people just don't use them correctly. Kind of like we saw with ranges. I mean, perfectly safe for the most part, with few exceptions when using them, but people, you know what, they'll leave them unattended or other reasons as well. Same thing with extension cords. I mean, perfectly fine when used correctly. You don't connect up extension cords to extension cords and then to other things. You don't try and go over the ratings of what they're actually rated for. Also, as far as like damage too, a lot of people will kind of use them as permanent wiring too, where it'll be left, for example, from your home connected to a detached garage, and then it's left there through the snow and through the years, and then so you'll get a bit of wear and tear that way. You'll have people who will drive over it with either lawn mowers or snow blowers, or it's wedged between a door frame and the corner, so then every time the door closes on it, that knocks a bit of damage onto it. Or under, I've seen it under like lazy boys, kind of like recliner chairs, things like that. So they're perfectly fine when used correctly. It's just a lot of people use them incorrectly. And if anything, it would almost be just more of like a public training, I would think. But it's hard to get that out to kind of everyone.
And I'll just add one more quick thing about that from what Tristan said. Properly used and properly certified, these are safe products.
Great. Well, thank you all for submitting all your questions and participating with us today. We have a bunch of questions that we unfortunately couldn't get to, but we promise to follow up with you in email form and answer any questions. So even if you have additional questions, speak now, submit them now, and we'll make sure to respond by email in the next day or two. Thank you all for joining us, and I also wanted to remind you guys we will be sending completion certificates in the next few days, so look out for those. And we also have another webinar taking place in the next 15 minutes on a second link. If you've signed up to that, look forward to seeing you guys there as well. Thank you all for joining us, and thank you, Tristan and Saeed, for your presentation.